So this video is going to look at National 5, the Converse of Pythagoras. The learning intention is you should be able to basically identify if a triangle is right angled or not. That's effectively what Converse of Pythagoras is. Prior knowledge is you should have a basic knowledge of Pythagoras before. For example, if you're finding the hypotenuse alongside, you would square and add the other two sides. And if you're finding a short side, you would square and subtract the other two sides. So, as I've already said, Converse of Pythagoras, it's using Pythagoras in reverse to actually prove that a triangle is right angled or disprove that. So, take you back to basics. Pythagoras discovered that on any right angled triangle, that c squared equaled a squared plus b squared plus c squared. So the hypotenuse squared was equal to the sum of each of the other two sides, 1 squared. So if the longest side squared is not equal to the shorter side squared and added, then it clearly can't be right angled. And that's what this thing here is. So you might not have seen this symbol before, but I'm hoping you have. So this symbol here means does not equal. Now before I actually go and show you the method I'm going to teach, to make you aware there are more than one way of doing this, okay? But from my marking experience, this is the easiest way to go about doing it and make sure you get full marks, okay? Oh God. So example 1, straightforward question is asking, is this triangle right angled? Now other examples in exams might talk about, is this town east of this town or south of this town or west of this town? Things that imply 90-degree angles in there. So it might not always say, is this right angled, okay? So Pythagoras, longest side is this one here. So this is our C, okay? So the 65 is the longest one, so this is our C. The other two count for your A and B. So what we do is, I like to use a little table method, and what we do is, it's basically splits up the Pythagoras. We don't have the equals there, so we're splitting it into two parts. So we're going to find C squared, so we're going to write down here that that is 65 squared. And the other side will be A squared plus B squared, so this will be 33 squared plus 56 squared. And then you work out what each of those two answers gives you, and we get 4225 and 4225. So, since each side of this table is correct, this is a right angled triangle. Now the really important bit about this is your conclusion, okay? We are going to then write a wee sentence, and we're going to say, so since 65 squared equals 33 squared plus 56 squared, by the converse of Pythagoras, the triangle is right angled. That is your key sentence that you must write. It must have this numerical bit here. Okay, you can get away with writing c squared equals a squared plus b squared there as well, as long as it's up here in your table as well. But I would just go with the numbers. And by the converse of Pythagoras, the triangle is right angled. So because our sum worked there and we got the same total left and the right hand side, it is a right angled triangle. Alternatively, you will see people go in and do 33 squared plus 56 squared, get 4225, square root it and say the answer is 65. But technically that's you doing normal Pythagoras, you're not doing the method called the converse there, okay? But key statement, okay, you must have that written, must. Example 2. So we have a rope and a flag on this one. The base of the ground is 13 metres, the height of the flag pole is 9 metres, and the rope holding it up is 16 metres. And it's asking you, is the flagpole vertical? So there's no mention of here, is this a right angle triangle? So you have to recognise by the question. Ideally, in a real world, the ground is classed as being horizontal, regardless of hills, okay? The ground should be horizontal. And things like flagpoles, lampposts, the sides of houses should all be right angled. So they could ask you something like that as well. So it's asking you to prove, is this a right angle? So we go and do converse of Pythagoras. So again, C is your longest side. So that will be 16 squared that goes in here. Your A and your B will be the other two sides, so 13 squared plus 9 squared. We'll go work out what both of them are. So we end up with 256 and 250. So in this case, we can see that the two sides of the table don't match at all. So our statement this time will be, since 16 squared does not equal, so an equal sign with a line through it, does not equal 13 squared plus 19 squared by the converse of Pythagoras, this is not a right angle triangle. Okay, so this is not a right angle triangle. And so the flagpole is not vertical, because remember we have to answer the question in this one. And so the flagpole is not vertical. Okay, so if it's not asking for right angled, if it's asking something about east and west or it being vertical, make sure you answer the question there, okay? One final example coming up. Okay, so there's one very similar to this in the 2019 exam paper, and really, really badly done because you were given the perimeter of this shape. So this one tells us that the rope that goes right round from P to Q and R is 9 metres. So you're given the perimeter of the shape, and a lot of people in the exam jumped in and used Pythagoras to try and work out what the third side of this triangle was, and then went to do converse, and then wrote their statement. But because they jumped in with Pythagoras first, instead of just working out what that third side is using basic S1 perimeter work, they were penalised a lot of marks. So be careful how you start these questions. We don't know if this is a right angle triangle. That's what we're being asked to prove, okay? So we've got 9 metres of rope. So your first sum is to do 9. Take away your 3.75. Take away 3. Which leaves us with 2.25. So one of our sides is 2.25. Okay, now it tells us QR is a 3.75. PQ is 3, and we've already worked out this one here is 2.25. So this is obviously the one they're thinking is a right angle, QPR. So they're wanting you to test what P is. Now, one way of doing this that I've not mentioned at all is you've been given all 3 sides in a triangle. You could easily go do a cosine rule. But you might be getting shown this and you've not been taught cosine rule yet, okay? So those of you who have done trigonometry, cosine rule for an angle would definitely work here, and then you would get an answer of 90, and your statement would just be angle is 90, hence it's right angled, okay? But I'm showing you converse of Pythagoras. But there is that other method there if you're familiar with the cosine rule for an angle. Right, so C is obviously our longest one, so we're going to have 3.75 squared on the left, and 3 squared plus 2.25 squared on the right. Now this will give us an answer of 14.0625 and 14.0625. Now look at that, they match. Now the question this time said, prove that it is a right angle. So if I came out and they didn't match, I've messed up and maybe got my numbers the wrong way around. So we have to then do our conclusion, which is again the sentence. So since, and I've just jumped ahead and written this in. So since 3.75 squared equals 3 squared plus 2.25 squared, by the converse of Pythagoras, angle QPR is a right angle, because that's what the question was asking. And then I added in this last wee bit, that triangle PQR is a right angle triangle, but that's just me trying to cover my bases and make sure I've answered the question properly. Okay. So what I've got now is 5 questions for you to go try yourself. We want to prove that these are right angle triangles. So you'll do your table. On the left hand side, always do your longest side squared. On the right hand side, square and add the other 2. If they match, it is. If they don't match, it isn't. Please don't forget that statement. It is so important. It's just one of those things in maths that you have to get the full marks at the end, okay? And you don't want to do all that work and then forget to write by the converse of Pythagoras it's right angled or not. So try them. Pause the video, then check your answers. And a quick what have we learned? So hopefully you've learned how to use the converse of Pythagoras. It's important. We've hopefully learned that your layout is so important, and there is more than one method. And we have also learned one of the most important conclusions in maths so far. You're going to meet a lot more of these when you get to higher. Thanks very much.